of researchers from the Technion Faculty of Materials Science and Engineering is presenting a new technology for producing green hydrogen using renewable energy. Their breakthrough was recently published in Nature Materials. The novel technology embodies significant advantage compared to other processes for producing green hydrogen, and its development into a commercial technology is likely to reduce the costs and accelerate the use of green hydrogen as a clean, sustainable alternative to fossil fuels. Using hydrogen as a fuel instead of coal, gasoline and natural gas will reduce the use of these fuels and greenhouse gas emissions from various sources, including transportation, the production of materials and chemicals, and industrial heating. Unlike these fuels, which emit carbon dioxide into the atmosphere when they combust in the air, using hydrogen produces water is and therefore considered a clean fuel. However, the most common way to produce hydrogen involves using natural gas or coal, and the process emits large amounts of carbon dioxide into the atmosphere, thereby cancelling out its advantages as a green, sustainable alternative to fossil fuels. In 2022, global consumption of hydrogen stood at approximately 95 million tons, a quantity suitable for improving various fuel products and especially to produce ammonia, which is needed for manufacturing agriculture fertilizer. Nearly all of the hydrogen that is consumed today is produced from fossil fuels, which is why it is called grey hydrogen made from methane or black hydrogen made from coal. Hydrogen production using these methods is responsible for around 2.5% of the annual global carbon dioxide emissions into the atmosphere as a result of human actions. Replacing grey hydrogen with green hydrogen is necessary in order to reduce these significant sources of emissions and replace polluting fossil fuels with clean, sustainable hydrogen. Various estimates predict that green hydrogen is likely to account for around 10% of the global energy market at net zero emissions. The current target for mitigating climate change and global warming as a result of the greenhouse effect due to increased concentration of carbon dioxide in the atmosphere. That is the reason for enormous importance of green hydrogen in combating global warming. Yeah, green hydrogen is produced through electrolysis, electrochemical decompositions of water into oxygen and hydrogen using energy from renewable sources such as wind and sun. Electrolysis was discovered more than 200 years ago, and since then it has undergone many developments and improvements. However, it is still too expensive for producing green hydrogen at a competitive price. One of the technological challenges that limit the use of electrolysis for producing large amounts of green hydrogen, amount that would help achieve plans to attain net zero carbon emissions, is the need for expensive membranes, gaskets and sealing components to separate the cathodic and anodic compartments. Several years ago, Technion researcher presented an innovative and efficient electrolysis techniques that does not require a membrane and sealing to separate the two parts of the cell. Since the hydrogen and the oxygen are produced at different stages of the process, unlike in regular electrolysis where they are created simultaneously. This novel process called E-TAC was developed by Dr. Hen Doughton and Dr. Abigail Landman under the supervision of Professor Abner Rothschild and Professor Gideon Gardner. They partnered with the entrepreneur Talmon Marco to fulfill the process's potential and develop commercial application. The researchers from Professor Rothschild's group at the Technon are now presenting a new process whereby hydrogen and oxygen are produced simultaneously into separate cells, like the E-TAC process where they are produced in the same cell but at different stages. The new process was developed by Ilya Solvokhin as part of his master thesis with the help of senior researchers Dr. Elena Davroda and Dr. Anna Bretiors and master student Metan Sunnis. Bien the report.